We begin with a scene 1 meter wide which we view from just 1 meter away. The sleeping man is having a picnic on a Miami golf course. As we back off, the clock starts, and we accelerate in such a way that after 10 seconds have elapsed we will be exactly 10 times farther away. Now the scene is 10 meters wide, and in 10 seconds it will be 10 times that wide. The sleeping man is still in the center and will remain there long after he is lost to sight. After the second 10 seconds, the square we see is 100 meters wide, the distance a man can run in 10 seconds. Now a kilometer, 1,000 meters, the distance a racing car can drive in 10 seconds. Picnic is about lost as we begin to see Miami Beach. 10 to the 4th power, 10,000 meters, the distance a supersonic aeroplane can travel in 10 seconds. 10 to the 5th power, a 1 and 5 zeros, the distance a satellite in orbit can cover in 10 seconds. Our speed is growing at a tremendous rate. In these past 10 seconds we will have covered almost 1 million meters. The Earth, that will be all but gone in about 20 seconds, looks solid and imposing and remarkably spherical. 10 to the 7th. Our speed is now about 2 million miles an hour. 0.3% of the speed of light, growing fast. A beam of light on the same plane as Earth would travel this far in 1 second. We can now see the orbital path of the Moon around the Earth. As our speed gets to be a substantial percentage of the speed of light, it has an effect on our time scale. What seems a normal 10 seconds to us would be a much longer period in relative Earth times. Our clocks are getting out of synchronization. Now a long time elapses on Earth to reach 10 seconds of our traveling time. The clock is spinning round. The light from the Sun appears, and parts of the orbit paths of some of the planets, Mercury, Venus, Earth, and Mars. 10 to the 12th. Considerably farther away is the outer group of planets, so that we now see our whole solar system. Because they are so much farther away from us than the Sun is, the stars seem to stand still. The entire solar system can now only be identified as light from the Sun. The ancient constellations demonstrate the direction in which we are traveling, perpendicular to the plane of the Milky Way galaxy. A supernova, an exploding star, flares. We are now 1 light year away, 10 to the 16th meters. We are approaching the distance of the closest star to the Sun, Alpha Centauri. Now our speed is so great that even the stars in the background slowly seem to change their position, converging to the center. The closest stars form a local group which gives another dimension to the sky. 10 to the 18th. As we back into the nebulous material of the Milky Way, we lose all familiarity with our surroundings. Gases and small stars of different kinds surround us. Now we are beginning to see the tremendous cosmic form of the Milky Way galaxy, of which the Earth is such a tiny and insignificant part. All the stars we see from Earth belong to this one galaxy, which in turn belongs to its local group of galaxies. These form part of a grouping system, much as the stars do. They are so many and so varied that from this distance they appear like the stars from Earth, although of course each spot of light now contains many millions of stars. Were we to continue our journey, the scene would probably now remain much the same. Spots of light might just get smaller. The picnic on the golf course will be a sped-up reverse version, reducing the distance to the Earth's surface by 1 magnitude every 2 seconds. Every 2 seconds we will appear to cover 90% of the distance back to Earth. We notice the rhythm of change between periods of great activity and relative inactivity that will continue all the way down to our next target, the nucleus of a carbon atom just beneath the skin on the hand of the sleeping man at the picnic. Enter the 9th meter. Enter the 8th, 7, 6, 5, 4, 3, 2, 1. We are back at our starting point, and now slow up on 10 centimeters, then to the -1 meters. Again, in each 10 seconds we will cover 1 magnitude of change. Enter the -2 meters, 1 centimeter, coming in on 1 millimeter. The surface of the skin looks rough and furrowed. The outside layer contains dead cells which we constantly shed and replace from within. Within the skin, the dark area we see is a tiny blood vessel, a capillary. The blood it carries is made up of different types of single cells. This cell is a leukocyte. It is self-reproducing and one of those which contains in its nucleus all the genetic material, the 23 pairs of chromosomes that humans carry. The scene is now 1 micron wide, 1/1,000,000th of a meter. Chromosomes appear to be made up of donut-shaped parts strung together. Within the chromosomes we find the genes. Each gene contains endless spirals of stringy material, deoxyribonucleic acid, DNA. The DNA structure contains all the hereditary information. At this scale we build models to represent the form of the atom, from information about the components, their size and movements. This is a single carbon atom. Carbon atoms are present in every living thing. An outer shell is defined by the orbital path of 4 spinning electrons, 1 angstrom. Passing through this shell we see an inner shell, 2 electrons orbiting to prescribe a sphere. Within the second electron layer we find what seems like a vast nothing. In each 10 seconds we still cover 90% of the remaining distance to the center. Finally it begins to appear, that unimaginably dense nucleus of a carbon atom, 12 orbiting parts, 6 protons and 6 neutrons. Our galaxy is 36 powers of 10 larger than the nucleus of a carbon atom. If the diameter of the atomic nucleus were a unit 1, then the diameter of the galaxy in atomic units would be 10 to the 35th, or 1 and 36 zeros.